स्क्रीन दिसता. आता आणि आवाज येता आणि हे कितें म्हणटा तें चॅट म्हाका कशी कळटली? खंय थंय? कसाचो? आता बंद केला डिस्प्ले कॅप्चर. मागीर you'll begin in a little minute. Huh? So, hello, good evening, everybody. I hope I'm audible to you all. Please give me a thumbs up if I'm audible. Good evening to everybody. There will be a little latency because I believe that that is very intrinsic about YouTube. So, however, you will be able to go very slow. If you want, you will be able to uh, slide backward, and if you missed onto something, you'll be able to cover up. You can also drop a message whenever you feel that it is required. And I'm hoping that you have already installed QGIS, and that is exactly what you see on the screen right now that I have opened. Connected, it is reconnecting. Good evening, everybody. I hope I'm audible to you all. Let's get started. I believe it's already 8 and the rest of the participants might keep joining in. Let's get started. So, before we get into this, let me tell you this one thing that you need to know while we are going through this session. It is just for 1 hour, and I expect your complete attention to this particular class. Look at it as a technique that you are learning. Before that, just give me a thumbs up if you're able to hear me, right? If you're able to hear me well, please give me a thumbs up and listen to what I'm saying. So while you are learning through this 1 hour class, I would want you to look at it as a technique that you are learning that can be employed at yet other places. Don't keep it only into isolation wherein you're using it only for groundwater mapping. You can basically create any kind of map that you require. Okay, all right. So please look at it in a wider perspective wherein you are learning the technique and you're able to apply it wherever that you feel like, yes, it is holding true at a certain, for a certain kind of map that you need to prepare because you have field data. Definitely go ahead. So don't look at it in isolation. That's all that I would want to tell you. All right. Now, I have opened QGIS interface before me. Don't be worried, be comfortable, even if you haven't used QGIS before any time. So don't be worried. Now, okay. So I have opened QGIS interface on my laptop and I need to bring in, so don't worry, even if you have never, yes, I think I can speak a little louder. Am I audible now? I hope I'm audible to you all. At any point of time, if I become inaudible or my voice is very shallow, please let me know. So, I have opened QGIS interface on my laptop and I don't want you to be bothered with the different types of tools that you see here. My interface might be looking a little different, but don't worry, yours will be much easier to wander around. Okay. So now what I want you to do is I want you to bring in a shapefile of any district or any taluka that you are interested in. How do you bring about that? Don't worry, we will start from the very start. Okay. So what do? We come to plugin section. Okay. You will see this is the menu bar. Then there are some horizontal tools here. And then you have a processing toolbox here. And you have layer section here. Okay, towards your left hand side you have layer section, towards your right hand side you have processing toolbox section, and in between you have a vast canvas, a large canvas that we call map view. Okay, this is where you will be viewing your maps. These are the horizontal toolboxes, and this is your menu bar. I believe you have already gone through the tutorial video that was shared with you for installing QGIS. Now come to the menu section. What is our aim? The first aim is to bring any shapefile that we are interested in. Eventually, you will end up using the data that I am sending you, and after the class, you will be using your own data set. So right now, be comfortable. Come to this plugin section in the menu bar and come to manage and install plugin. Okay, I'm going to go very slow. It's nothing difficult. So I will be going very slow. What did I do? I went to the menu section where there is plugins. I came to plugins and I went to manage and install plugin. And I'm waiting for a while so that it um, uh, gets retrieved, and I come to the all section. If you are in installed or not installed, upgradable, or installed from zip or settings, come back to all. Okay, and search for something called HCMGIS. Search for HCMGIS. Okay, what you're searching for? You're searching for HCMGIS. This is the plugin that is going to help you in bringing an administrative boundary shapefile for your study area. It could be a district, could be a taluka, could be an entire state. Okay. So I select this particular HCMGIS. You will be able to see this symbol, yin kind of symbol, yellow and blue color. And you're going to install this. So you will get an option called install plugin. I'm getting this option called reinstall plugin. So I'm clicking on that. So I will click on this install plugin and install this. Okay. Now once it is installed, I will be able to see that HCMGIS is an added section in the menu bar. Now I can close this down. Close this and you will see HCMGIS in your menu bar. Now this is where you can go to download open data. So some data that is free of cost, but make sure that you are connected to the internet. If you're not connected to the internet, your plugins will not get installed and hence you will not be able to download any data as well. So I want you to be connected to internet. QGIS is a freeware. It's a free software. So come to this download open data section where you have global administrative areas by country from GADM. So open this particular section. What you're opening? You're coming to HCMGIS, download open data, and there you're going to global administrative areas by country from GADM. Let's click on this so that you will be able to see a panel like this. Okay. Now here, definitely I want to select the country of my interest. Any country you may select. I am interested in India. So I search for India, select India. Now, remember that there are 4 levels of data in this particular shapefile. 0th level, that is first level, is country shapefile. Second level is state shapefiles. Third level is district shapefile. And the fourth level, that is level 3, is your taluka shapefile. So I want all of them, and I will browse into my system and I will create a folder on my desktop. On my desktop, what am I doing? I am creating a new folder. And to this new folder, I am naming open session. Okay. And I'm using an underscore to separate two words. Okay. You see, open and session, there are two uh, words, no? Open and session. So what am I doing? I am placing an underscore in place of space. Keep this in mind because you're going to do this all throughout. Whenever you create a new file, you're going to use an underscore to separate two words. So I create an open session folder. I browse into it, and this is where I select this folder where these administrative boundary shapefiles will be selected, will be stored. So what do? I select this folder. Okay, what did I do? Once this folder opened, I browsed, made a new folder on my desktop by this name, open session. You see here, new folder. You can also right click and go to new and use this folder. I hope you will be knowing this. And then I am taking this particular open session folder, selecting that folder, and that is where our administrative file will be downloaded. Okay. And then I am clicking on apply. When I click on apply, wait for some time so that it will estimate what is the size of that particular data, that is administrative boundary data for that particular country. And it will be asking me that, okay, it will take some time. Are you sure you want to go ahead? I will say, yes, I want to go ahead. And then again, I will wait for some time so that this data will get downloaded and get populated within my layer section, and I'll be able to view it in my map view panel. Okay. All right. So now that we are here, I would want you to give me a thumbs up if everything is okay with you. Okay. Please give me a thumbs up if everything is fine with you. You're comfortable and you have understood this. It's loading. You will see that it is progressing. It will take a little while. On your system, it might be a little quick. I'm having a little internet connectivity problem, but that will only be about latency. Otherwise, things should be fine. Okay. So it will go all the way to 100% and it will get populated within my QGIS project. If on my screen it will take longer, then what I will do is I will bring about that particular data. Okay, that is what I will do. If it takes too long. So if on your project it has already been populated, then what you will do? You will just say done. Done. Okay, say done if your data set has populated. It has come onto your system. Okay, great. All right. Okay, yes. All right. Not a problem. Okay, yes, it will take time, a little time, definitely it will take. Depends upon how better is our connectivity. Okay. So what I am doing is I am opening QGIS again because on my screen also it was taking pretty long. So what I am doing is I am simply going ahead and bringing about this particular data set because I have already downloaded it. Okay. So that is what I will do. Okay. So now this is taking uh, 13 minutes. Okay. All right. So what I have done is I have shared, I've, I have shared this one link with you. Okay. Link to demo files. So if at all it so happened, that you were not able to, what to say, if you were not able to um, download this particular administrative boundary shapefile, then I want you to go to that particular link, and this is where you will see one folder, India shapefile. It's still uploading, okay? Just give it some time. But meanwhile, if yours is downloading, don't interrupt it. Let it go ahead, okay? Now, meanwhile, let me come back to this project. Okay, so what I will do, I will go to layer section. You might be having some data set, no? Vector files or raster files, or it might even be so that this particular data set that you have just now uploaded, someday you might remove it. So you would have want to add it back into your QGIS project. So what you will do, you will come to layer section in the menu bar and you will go to add a layer. Okay. And you will go to add vector layer. This is basically shape files. Okay. These are basically vector files or shape files, feature files. At the very end of this source, you will see three dots. If you hover mouse pointer over it, it reads browse. So I will browse into my system where I have already downloaded this particular data set. Now, don't be worried if you are not following this because I'm just going to that one folder where I have already saved this particular data set. Okay, that's all that I'm doing. Okay, and that shape file name or the folder name is India shape. So in your system also it will come like that only. So what I will do, I will select the shape files in some of your cases wherein it has already been uploaded now, or it has already showed up populated within your QGIS folder. You don't require to do this. Okay, you don't require to do this. You will already be having this. So right now I'm just copying this and I'm opening this data set and I'm adding it and closing. So this is how your data set looks, right? This is how your data set looks. So you have level 0, which is entire country boundary. Then you have level 1 data set, which is different states. Then you have level 3, which is, sorry, level 2, that is district shapefiles. And then you have level 3, which is taluka shapefiles. Okay. Now I am interested in this shapefile, that is shapefile of Goa. If I zoom in, no, then I see that the shapefile of Goa is here. But it is not separate. It is along with all the other shapefiles, boundary files of the other states as well. So what I'm interested in, I want to extract or export only the Goa shapefile. So what I will do, I will take this selection tool. Okay. This select feature by area, it looks like a yellow post-it note. It must be there here in your horizontal toolbox. So I take this and I select this particular shapefile that I am interested in. Yeah, I know the India shapefile is not an integrated one. So, but this is what the data is right now in open data store. Okay, so I'm really sorry, but that is how the shapefile looks in the open data. However, there are other integrated data sets of India shapefile also. So if we simply go to Google and search for download India Kashmir shapefile, India plus Kashmir shapefile, then you'll be able to find it. So don't worry, you will get ample of links to download that. Okay. Now, so what I have done, I make sure that I have the shapefiles are there in the they will be there. The folder must be already downloaded in the same folder that you had location that you had given. Okay. So what do we do? You select the shapefile where your interested boundary file is located. For example, if I'm searching for Goa shapefile, then I won't find it in this. This is the entire country shapefile, no? So I won't find it there. I won't find it even in Taluka shapefile. I won't find it even in this district shapefile. I will have to select both the districts if at all I want to. But I want to use this particular India 1, that is level 1 dataset. See that I have turned it into blue by just selecting it. Okay. And I have taken this select feature tool. Okay. It is in your horizontal toolbox. And I have selected Goa. Okay. Now I come to this level 1 dataset that I had selected. I right click on it and I go for export. Okay, I go for export and I say save selected feature as only the selected one I want to extract. So I will take save selected feature as. Okay, and what will I do? I will. Okay, if you're talking about the demo file, then wait, it is already uploaded completely now. Okay, you may go ahead and download it. Yes, from Survey of India also you can get. You will have to make an account on Survey of India, and that is where the shapefiles, even of village level, boundary level data set, is free of cost. Okay, you can make an account on Survey of India, and from there you can download. So right now, this demo file that I have uploaded of India shapefile, if you were not able to download it through that HCM GIS plugin, then you may go ahead and download it from here. The link is in our chat box. Okay, let me come back here. So I have selected Goa and I want to export it out and keep it store it separately. And I have to give a file name. So what I will do, I will use this last three dots, browse into the folder that we have just made on our desktop. Open session is the folder that I have made, and I'm going to call it Goa. Okay, and underscore UTM. I'll tell you what exactly this UTM is. Okay, and I will save this. It will get saved as ESRI shapefile. If it is anything else other than that, maybe Geo package or something like that, then please change it to ESRI shapefile. Okay, and what will I do? I will change this coordinate system. I want to change it to UTM zone. Now, what exactly is UTM zone? I would want you to find it out. Universal Transverse Mercator. It divides our entire globe into 160 stripes towards north and 160 stripes towards south of equator. Okay. And it helps in making that curved surface of the globe as a straight planar strip. Hence, calculating area, measuring angles, or measuring length, perimeter becomes very easy. Otherwise, on a curved surface, it becomes difficult. So I know that Goa falls in UTM zone 43. Okay. UTM zone 43N. And that is why I am taking this. If you don't find it here, you can also take this globe and search for it. UTM. You can search for it and you'll be able to find both. North, that is N, is northern hemisphere, S is southern hemisphere. So you will have UTM zone 43 in northern hemisphere, also in southern hemisphere. But because Goa lies in northern hemisphere, I've gone for 43N. Okay, I've selected this and I'll just wait for some time before I tell you how to find out which UTM zone your study area lies into. And then once you have done this, you can go ahead and click on OK. Once you click on OK, no, you will see that Goa shapefile has been populated. Let me just deselect everything. So right now you see that it is selected. If I choose this, no, deselect feature, then everything will be gone. There is a shortcut also to it, keyboard shortcut, Control Alt A. Okay. Now let me show you Goa shapefile. This is Goa shapefile that I have extracted. Now this Goa shapefile is also there in your um, uh, in that Google Drive folder that I have shared with you as demo folder. Okay, you can find it there as well. Now we have our study area set. It might be that you are working on a completely different data set. In that case, what will you do? You will come to Google and let's say I am working on Delhi. Delhi UTM zone. That's all that I will type. Okay, Delhi UTM zone and I will enter. So what I will get? I will get a zone for Bhubaneswar. Okay, I want to find out what is the UTM zone for Bhubaneswar. And I'll be able to find out which UTM zone it belongs to. It belongs to UTM zone 45N. Okay, very simple. Please give me a thumbs up if you understood this. Hmm? Just give me a thumbs up if you understood this. This will help you in identifying UTM zone, that is Universal Transverse Mercator Scale coordinate system, that is used for measuring area, measuring length, perimeter, angles. It helps you in doing this. Geographic coordinate system will not help you in doing this. WGS 84 will not be able to help you in doing this. Okay. So once you have done this, you know that you have the shapefile. If you are using the downloaded shapefile that is in the demo file, then also you will have to right click and export it, and that time you add it into UTM zone. Okay. Or directly it won't be in UTM zone. So I would want you to perform that particular exercise wherein you're converting it into UTM zone. Now great. The next thing that we want is groundwater level data. Okay. Now, I want you to go back to Google, okay, and I want you to search for this particular keyword, groundwater level monitoring. Very simple. I'm copying this and I'm giving it to you in our chat box. Search for this on your Google search engine. Okay, just search for this. When you search for this, no, you will get the very first link, that is groundwater level monitoring. Now, Central Groundwater Board has many observation wells and test wells all over the country that it is managing. What it does, it keeps finding out what is the water level or depth to water table from the ground, depth to water table for every season. They also collect that water and analyze it so that its chemical analysis data is also available. Where do we go finding it? We go to Central Groundwater Board website and specifically this particular link. Okay. So this is the link where you will end up. Let me copy this and share this as well with you. This is the link that we are at. Okay. Now, every year for every state, groundwater yearbooks are published. For almost all the states, groundwater yearbooks are published. So you have to scroll down to the first source that is available here. I have scrolled down. To groundwater yearbook. Okay, this is where you will see groundwater yearbooks for entire India, then Goa, Kerala, Rajasthan, Andhra Pradesh, Haryana, Maharashtra, Dadra Nagar Haveli, then Tamil Nadu and Union Territory of Pondicherry. Then you have Bihar, Himachal Pradesh, Madhya Pradesh, Telangana. Then you have Uttar Pradesh, northeastern states. So many northeastern states together, Jammu Kashmir, Ladakh, then Chhattisgarh, Delhi, many different states. Okay, almost all the states are covered, you including the union territories. Now I want you to go to any of this link or any of this state that you are interested in. Remember that in one at from one point we will all go synchronous, but right now I want you to try explore around with me. So we go to, I am interested in, let's say, Goa. So I go to Goa. When I click on Goa, see it is link is embedded into those states. Okay, so you have to select on it, click on it so that you get into that particular uh, link where all the groundwater yearbooks are available. So you will see that it follows this year trend, that is 2013 to 14, 14 to 15, 15 to 16, 16 to 17, 17 to 18, all the way until 2024 to 2025. Okay. Now, here, I will go for either viewing or downloading one of the yearbook. Now keep this in mind. What am I doing? I am opening, or rather I am viewing 2023-2024 dataset. I am opening it in a new link. Okay. Server error. Let me try again. So I go for just downloading. Let's see if that works. Yes, it works. Okay, so it is letting me download. What am I doing? I'm going back to my same folder that I have made and I'm giving it groundwater yearbook. I know that it is 2023, 2024. See the way I'm naming them? I'm making sure that I'm not using spacebar. I'm using an underscore to separate two contents of the file name. Okay, and I'm saving this. Okay, so it is saved. Let me open it for you. This is how that groundwater yearbook looks. So depth to groundwater level maps are prepared. Okay, depth to groundwater um, level maps are prepared. We go all the way down to annexure 1. Almost in every it is the same. Annexure 1. Okay, annexure 1 to the very end. You can also go to the content section and look for what is the page number of that annexure 1. And here you will see serial number, district from which this particular groundwater level is monitored. Okay, then each well is given an ID, then which taluka it falls into, what is its location, that is specifically the village in which this particular well is located, what kind of well it is, whether it is a bore well or it is a dug well. Then for May 2023, what was the depth to water table? Okay. Then in August 2023, what was the depth to water table? That is, May is pre-monsoon, just before the onset of monsoon. August is during the monsoon. November is post-monsoon. That is when the aquifers will be, filled up to its maximum. And then January 2024, that is post monsoon. So post monsoon has almost finished. It is almost that the summer is starting, and that is where another groundwater depth is taken. Okay. Now we require this data set along with the latitude and longitude. But right now in this particular file, you will see that the latitude longitude is not there, which is a big problem. We want latitude, longitude. We want to know where exactly in this particular village, where exactly that particular um, well is located. Correct, no? So what I will do, often what I told you, every year Central Groundwater Board is not going to go for digging up new wells. They already have some wells to which latitude, longitude data maybe they did not give in one groundwater yearbook, but it must be available in another. So what do? I go back and download yet another. Okay, I go and download yet another groundwater yearbook. Okay, so this was 20. I'm just taking this and making amendments to the same name. Okay, and I'm saving this. Okay, very simple, very simple. And I'm opening this. Again, I go all the way to the annexure 1. So here also I don't see it. All right, I don't see the latitude, longitude here as well, but it's okay. I can go for yet another. Let me go for this. Okay. I'm just giving you enough time so that you realize what exactly I'm doing. Huh? Keep that in mind. 2024 to 2025. Not an academic year. Okay. So let's open this. We go all the way to the now here you see, in this particular table, we have the latitude and longitude. What do we have? We have the latitude and longitude. Now, if you want to trace it back to which particular well it belongs to, you can go for this well ID, or you can go for the village or location which it belongs to. In the same village, it is very unlikely that there will be two wells located, okay? Because it will be too demanding in terms of finances, isn't it? So you will be able to find latitude, longitude, some or the other way. If it is not present in one groundwater yearbook, in another. If you're not finding it and you feel that this kind of data is very much required to you, reach out to the state central groundwater board branch, okay, and they will be more than happy to provide you with this data set. So we require latitude and longitude, and we require what was the groundwater depth from the ground, what was the depth to groundwater or water table that we call, for different months. So for May 24, August 24, November 24, January 24, by far this will be the way it will be available. Now, I want you to convert this data into an Excel file, okay, into an Excel sheet. What are the things that you will require? Latitude and longitude compulsorily, and you will require what was the depth to water table in different months. If you feel that district, then taluk, that is tehsil, then village, and this well ID is also important to you, bring that also in your table. Don't worry about it. You need to have proper table that you make during collection of data. Okay. Now let me show you one such data set. Okay. This file I have already provided you in our folder that we are sharing. Okay, this particular folder that we are sharing, where you have demo file. Okay, Central Groundwater Board Goa water level for 2024 and 2025. So this particular Excel file you can download. Okay, this is a simple data file. No, just give me a thumbs up if you will be able to make a file like this. Give me a thumbs up if you will definitely be able to make a file like this. Very simple. This particular thing could be anything, any kind of data set can fit into this kind of a format, isn't it? Excel files, you already make these at a certain location. This was the soil moisture content, or this is what I prepared, things like that, right? Okay. Just give me a few thumbs up if you have understood this. You can also give a thumbs down if you have not understood something. Okay. Please feel comfortable because you are here to learn the very, very fundamental tools. We're not learning anything difficult. Don't worry about it. Okay. So now what I have done, I have already sent you this particular file, that is the demo file. Okay, this is how it looks. And it has some 81 file, 81 data sets are there. Okay, at some places there was absolutely no measurement was not taken. If you want, you can get rid of them. You can just remove them. Anything. Okay, anything will do. I'm not removing them, just keeping them as it is. Okay. Now, this Excel file, I cannot directly import and integrate in QGIS. I have to first convert it into a most compatible format that QGIS is able to recognize, and that is CSV. What it is? Comma separated values. Okay, comma separated values. So what do? I come to file. Okay, and I go for saving this particular file as, yet again, I go into my system where I have created a folder on my desktop, open session. This is where I want to save this, but do I want to save this as Excel file? No, I want to save it as CSV file, that is comma delimited or comma separated values. CSV. Okay, you will find it here. Drop it down. You see, save as type. Okay, this is the same way you convert it into PDFs and things like that as well. If you want to create it, convert it into PDF, you are able to do this. And I want you to go for comma delimited dot CSV. Very great. Okay, very, very simple. CSV. Great feature that helps us in converting one format to another. We require CSV that will be compatible with QGIS. And what do? I click on save. I saved it. Okay, I have saved it. I have saved it as CSV file. If I keep it here, it will be CSV file. Let me close this. Okay, CSV file. No, I have already saved it, so don't say. Okay, I have already saved this. So what did I do? I gave you an Excel file and I expect you to convert it into CSV file. Please keep that in mind. Okay, that's all. Now, give me a thumbs up if you have already converted your Excel file into CSV file. With a thumbs up, you say CSV. So I will know that you are giving me a thumbs up for that CSV file conversion. Let me give you 1 minute. You can do this for n number of data that can be put in this format. What is that format? Latitude, longitude, data, 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 data. Okay. You can make maybe different tables, different columns for different season. Not a problem. Okay. So what am I saying? I'm saying give me a thumbs up with CSV. That means I will know that you have been able to convert this Excel book into CSV. Okay. Very simple. I'm not teaching you anything difficult. Everything is very, very simple. Even if you are using QGIS for the very first time, believe me, you will be able to do this and you will be able to do it for many different data set. Okay. All right. Okay. So now I want to bring that data set in here into QGIS. How do I do it? Very, very simple. I come to again layer section in the menu bar, and that is where I go to add layer, and here I have yet another section, that is add delimited text layer. So I will go for this. Okay. Add delimited text layer. Okay. So this is what I have taken. Even if you go to vector, you will see it here, delimited text. Not a problem. Even if you take this, no? So if you take add layer, add vector layer, from there also you can go to delimited text. Okay. Very simple. And now you will see file name at the very end of it. You will see browse, these three dots. If you hover mouse pointer over it, it says browse. So I go to the folder where I have saved this CSV file. You see this CSV file, this demo CSV file, and I will open it. I will open it. Okay. And what will I do? I will go for, this is a CSV file. Everything is fine. You scroll down and you will see latitude, longitude, May 2024, August 2024, November 2024. If you don't see this, then you will be under stress. Now, in what scenario these columns will not come? If there is a space between May and 2024. So if it is May space 2024, then you will have to make the changes to your columns. Only then you will be able to do this. Okay, keep this in mind. So make sure that there is no space you are using whenever you are using QGIS. If at all you must use a space, use an underscore to separate two contents or two names within one file name. Okay. Once this is done, you want to choose your geometry coordinate system. Which one you will choose? You will choose UTM zone 43. Okay, make sure that this DMS coordinates is not ticked on, because this is not degree minute second. What it is degree decimal. It is degree decimal. Unless and until you have converted it. If you have converted it to degree minute and second, then you tick this on. Okay, so I will go for choosing UTM zone 43, which it belongs to, and I will simply click on add. What I will do? I will simply click on add. Just give me a second. Okay, it seems it has been added, but it has been added at a wrong place. So let me just, because how do I know that it has been added at a wrong place? Because on top of Goa, there is this dot files, but I'm not able to see it. That means something has gone wrong. Maybe my coordinate system is not working. So I will just remove this, okay? I'm just removing this. I hope you understood why I'm removing it. Because this UTM zone is right now not working on it. So what I will do, I will change this to a default, that is WGS84. I will simply change it to WGS84. And now, yet again, let me just browse in and bring that CSV file. And this is fine. Let me add. When I add, now I see that the dots have come. Now the dots have come. Now what I will do, I will close this. Okay, the dots have come there. Wonderful. If I right click on this and open the attribute table, then I'll be able to see the same table that I had uploaded. Okay, the same table I am able to see here. Same table, the same table. Okay, now what do I do? I will close this table. I know that the table has formed, but I want you to know one thing. What is that one thing, you know? I want you to know that right now we are dealing with something called depth to groundwater. We are dealing with something called depth to groundwater. But it is not just depth to groundwater that we require. What we require is, have a look at this. What we require is water table elevation. Now, depth to water table is measured from ground elevation to the depth at which water table is encountered. But what we want to know is what is the potential height of the water table. That is, with respect to mean sea level, what is the height of water table? Which we will get to know only when we know what is the land surface elevation and what is the depth to groundwater. So what do we need to know? We need to know wherever this well is located, what is the exact location of that particular well, at what height the ground is situated, what is the height of the ground with respect to mean sea level, and from that ground at what depth the water table is encountered. So what we will do? We will go for subtracting the depth to groundwater from the elevation of the ground. That will give us water table elevation. If you remember, when we go back to this particular groundwater yearbook, look at it very carefully. The kind of maps that are given are what? These are depth to water table map. Okay, what they are? Their depth to water table map. They are not elevation of water table. That is, they are not representing the potential head. When we know where the what is the potential head at a given point, only then we will be able to find out the true fluctuation maps. It is not going to be only the depth to water level. Near a river, water table will be shallow, but at the peak of the mountain or somewhere in between along the slope, the depth to groundwater will be deeper, isn't it? But still it will be at a higher elevation. So water that is available at deeper depth at the slope at the mountain, it will still be moving from the higher potential towards a lower potential that is near the river. That is why identifying elevation to groundwater or water table is important, because of which we require groundwater elevation. Now, where do we get groundwater elevation from? If we have some elevation surveys done for a given area, then definitely we can go for it, high resolution data set. But in absence of it, if we are doing it for a large area, like in this case, the methodology remains same. The tools that you are using remains same. Please keep that in mind. What do we require? We want to go to this particular portal, that is USGS Earth Explorer. earthexplorer.usgs.gov. This is what I had asked you to make an account upon. Okay. So let me share this particular. You may, provided you have been able to convert the what is that? Provided you have been able to convert that PDF table into that CSV file. Okay. But in absence of it, don't worry about it. I want you to go to this particular demo Google Drive folder that I have shared a link to in our chat box. I hope you are able to access it. If anybody is not able to not access it, please drop a message asking Google Drive question mark. So I will get to know that you want that um, uh, Google Drive folder link. Okay, so I want you to go there. This is where this demo file is located for the state of Goa, and Goa shape file is also there. Okay, now let me go back to Earth Explorer. Now I want these SRTM, that is Shuttle Radar Topographic Mission, uh, which is a DEM file for the state of Goa. Okay. So what do? I make sure that I'm logged in, which means that your username has to show up here with a logout signature, logout option that helps you to log out because you are already logged in. Okay. If it says login, then log in. Okay. If you have not created an account, make an account, but give it some time. Have a look at this. So right now you see a map view here also. You want to zoom out. Okay. I want you to zoom out. Okay. I want you to zoom out and go to the area for which your data set needs to be downloaded. You will see all these names here. If at all it becomes very difficult for you to go to the area for which you want to download the data set, I want you to download the data set for your study area so that if you face any difficulty, you will be able to tell me. If you happen to not download, don't worry, you will have it in the demo file. In the demo file, you will see merge Goa SRTM, which is a 22 MB file. You will be able to download this. Okay. This is what exactly we are doing. So I come back to this Earth Explorer and I go to search criteria. By default, you will be there in the search criteria. Okay. So from here, what do? I go to polygon. Okay. You scroll down, go to polygon. Okay. And you say use map. Just click on use map. So you will see your map view entirely turns into red color. Now I want you to zoom out. What you will see? You will see that these four balloons are completely covering your area. If they are not, you are able to move them. Hold these balloons and drag them to wherever that you want. Okay, like I am doing. What am I doing? I'm dragging them and putting them such that it is covering the entire study area. Once this happens, you can go and click data sets. Okay, you are downloading SRTM. Don't go for adding any date range. If you are downloading any other data set, spectral data set and things like that, multispectral images, then you may go for doing that. But right now, I want you simply to go for data sets. And here you will see digital elevation option. You drop it down. And here, in the digital elevation, give me a second now. In the digital elevation, you will see SRTM. So you choose this SRTM, and from here I want you to go for SRTM void field. Okay. I want you to go for SRTM void field. Make sure that you tick it on. Okay. Make sure that you tick it on. And once you tick this SRTM void field, go for clicking on results. Go for clicking on results. It will search for this SRTM dataset. Give it some time. Let it search for it. Okay. And then it will populate all the data set that is covering your area. For example, let me show you footprint of this. See, only this part, this much part is getting covered. Then if I choose the other, see, only this part is getting covered. And then if I choose this third one, this part is getting covered. Here there is none because there is no land here. It is basically only the open ocean. So I'm not, I don't need to have any data set for there. Okay, because this is elevation data set. So what I will do, I will go for clicking on the small download options here. Okay, when I click on download option there, okay, then you will be able to download this GeoTIFF 3 arc second. You can download the other ones also, not a problem. But right now, for an easy go, I want you to go for GeoTIFF 3 arc second. Click on download. Once you click on download, it will I ask you for where would you want to save this data set. Then direct it. I hope it is working. It should work. Okay. So let me know if anybody could download it, okay? For me, it's just throwing some errors. So meanwhile, what I will do is, because I'm not able to download it, let me just see if I'm able to download any other. It gets downloaded. Often there comes some, I don't know, some kind of troubles. Right now, it's throwing some internal server error. But this is how you go for downloading. Just click on download. It will open a new pop-up. And then don't close that pop-up. Just let it direct you to the folder where you would want to save your dataset. That's all. But right now, because it is not, I am sending you these files. Okay. These are the three files pertaining to the state of Goa. Okay. These are state of Goa. I would want you to download them from here, from your demo file. Wait for, give it some time. In 1 minute, it will be uploaded. Okay. While this happens, let me show you a simple way. Now, what I will do, I will go to layer section again, add layer, add raster layer. I'm adding raster layer. This time these are photographic dataset. I browse into the folder and there I will go to that specific folder, but right now you will see me going to somewhere else. So please excuse me for that. And I will search for these files. Yes, here they are. There. Here. So there are three files, okay? Three independent files. I'm opening them, adding them to the map view, closing. So what do you see? You see that there are three files. One, two, three. Okay, these three files, when I put them together, only then they are covering the entire state. So what do I want to do? I want to merge them all together such that these seams that you see will not be there. These seams, these junctions that you see, very crisp, boundaries between these files are not there, and you create one file. Okay. Please find these files in here. They are already uploaded. You will see N. They start from N14, N15, N15. So these three files I want you to bring in. Okay. This is where it comes. You come to layer section, add layer, add raster layer, bring in those three files. Okay. And then add them and close. So you will see them here. But I want to create one um, coherent file. So what do? I go to raster. You see this raster section in the menu bar. Here I will go for miscellaneous. Okay. And under miscellaneous, you have something called merge. Under miscellaneous, you have something called merge. I will take this merge option. I will take this merge option. And what will I do? I will add these three files. Okay, I have selected them all and I've clicked on OK. You see input layers, you come here, add all these three files. Don't add any other. Click on OK. Three input files. Okay, everything seems fine. You want to save this not as a temporary file. So you go to the very end, save to file. And what will you do? You will save it in your folder. So because I have made a specific folder, let me save it here. I will call it merged SRTM dem. See that I'm not using space bar, I'm using an underscore. Okay, I will click on OK. M is also capital. Save. Okay, and then I will run this. Will simply run this. So what will happen? It will generate a coherent file for me that doesn't have seams. So what I can do, I can simply select these all, right click and remove the layer. Just remove this because I am interested in this particular shape file. Okay. So these are the DEM files. These are the independent DEM files. N14, N15, N15. This is what you will require. Okay. So we have merged it. Now let me take 1 minute break and let me ask you if you're stuck somewhere. Let me know if you're stuck somewhere. Downloaded. Okay. Downloaded. That's okay. That's okay. So what I want you to do is finding that appropriate yearbook might take a little longer. It's all about the data availability. So what I want you to do, I want you to use these demo files that I'm giving you so that you will be able to carry on. Okay. And then later when you get the appropriate data set, you will definitely be able to generate your own files and integrate them in GIS. Okay. So some of the files definitely it might be that you won't find it in the first yearbook. You will have to go back, then still go back, find where exactly this latitude longitude is there. For all the states, basically, you will find the yearbooks. Okay. The yearbooks will be there for all the states. So I go for Chhattisgarh. In one of these yearbooks, you will definitely find latitude, longitude. I hope that is what you are bothered about. Okay. All right. Now, I want you to go back to this particular demo file, that is CGWB demo file. Okay. I want you to go here. I want you to go here. Now, what exactly is this? If I go to the attribute table of this, you will see groundwater depth, that is depth to groundwater. But what we do not have what is the elevation of groundwater. Correct? No. That is what we want to extract. So what will I do? I will go for just give me a second. Yesterday, I'm just forgetting the name of that particular. Where exactly is the session 2? Mm, s- this little difficult. Just give me a second. Meanwhile, if you have any query, please ask, okay? If you have been facing any difficulty, please ask. While I'm just searching for the name of the tool. It's during this important times that certain things. क्या है? हाँ? Simplicity. Huh. Okay. So we go to the processing toolbox, raster analysis and sample raster values. Okay, sample raster values. That's the tool that I'm searching for. Okay. So to raster analysis in the processing toolbox, I come to raster analysis and here I search for this tool that is sample raster values. In oh, okay. Okay, that's making an account in Explorer will be a little easy. Make sure that you're using an active file. Okay, that's all. So we come to raster analysis, and under raster analysis, you have this particular tool that is sample raster values. So let's go to this particular tool that is sample raster values. Let me tell you what exactly this particular tool does. You give it a shapefile, that is in this case our demo file, the points that we have brought, and the raster layer is our dem file. Okay, we give both these to it, and what it does it is that it samples the raster values at those exact points. For example, if I was to show you here, let me bring this demo file on top. Okay, if I want to know what is the elevation at this particular point, then I will take this identify feature and I will sample this particular pixel where this point falls, and I'll be able to know that the elevation of it is 12, right? But doing this manually will take way longer. So what am I doing? I'm using this tool under raster analysis in processing toolbox, which is sample raster values. Okay, and here I will give input layer as this demo file, that is the shape file that we have created, and the raster layer will be this merged srtm dem. Okay, now when I do this, I make sure that the output column, I'm renaming it as elevation. You can give it EV. Okay, I'm just giving it an underscore also. Elevation, just give it this name. Okay, it takes around 4 to 5 characters. So please keep that in mind and accordingly you take. And now we will have to save this now. So I will save this to a file. And this time I'm going to save this as sampled. Okay, sampled elevation, ELE, elevation, and this groundwater depth. Okay, this is that file. So let me save this and I will go ahead and click on run. Okay, so what it will do, it will generate yet another file for me, which is sampled elevation GWD. It has created one more file. So this was the earlier file. This is a new file. If you want, you can also give it a different color. Okay, so if I was to give it a different color, maybe green, darker green, apply, click on OK. So this is green. The earlier ones were this uh, buff color. Okay, this is green. Let me know if you have not understood this. So what did I do? I went to sample raster values under raster analysis in the processing toolbox. If you don't have processing toolbox here, you can go to the section here that is processing and click on toolbox. So toolbox will come. You go to raster analysis, and that is where you will find sample raster values. All of these tools are arranged in alphabetical order. So go to sample raster values. Okay. Now give me a thumbs up if you have done this, because I'm redoing it. Our input layer is this demo file. Okay. Raster layer is this merged SRTM. If you have not merged your SRTM, find it in the demo file. Find it in this particular demo file that is shared with you. That is merged Goa SRTM. Okay. And then I'm giving this raster, and I am renaming this particular output column as elevation. ELE will do. Go for a capital because at times it doesn't take, mm, specifically it doesn't take. And then save this particular file that will be created to your folder. Give it a name and then click on run. Okay. That's all. Very quick. Very quick. Let me show you what is the difference. So if I look at this demo file, open its attribute table, I don't have elevation. I don't know the elevation. That is horrible, no? But I have created this sampled elevation file, which if I go to the attribute table of it, if I go to the attribute table of this particular file, then you will see elevation. Elevation is here. Right? Elevation is here. Latitude, longitude, May 2024, August 2024. These are all groundwater depth. I want to create groundwater elevation. So now for that, what am I going to do? I will require a new folder here. Right? I will require a new folder here. So what will I do? I will go for this open field calculator. You see this one tool here, open field calculator. Even if you hold the button and click on I, it will open. A panel like this will open. Okay, a panel like this will open. I want to generate what is a groundwater elevation at these points during May 2024. So what will I do? I will create a new field. Tick on this create a new field, not on virtual field. Okay, and I will create groundwater elevation. For what? For May 2024. Groundwater elevation for May 2024. That's all. May 2024. It won't take specific length. So that is why be careful that everything that you require is there. So that is why I have not used an underscore also. Groundwater elevation May 2024. That's all. What kind of field it is? It cannot be an integer. It has to be a decimal because I don't want to lose onto those points also. That is why I'm taking a decimal number. And then you come to here. That is in this particular expression box. Okay. Now in this expression box, I want to go for adding this particular formula. What is the formula? The formula is I want to find out water table elevation, for which I need to know what is the elevation and subtract depth to water table from it. So it is elevation minus depth to water. Depth to water we already know. So we come back here. See here what we will do. We will open quotes 2, open inverted comma. Okay. And what is that column? That column is, you see, May 2024. And this is elevation. So we need to go for first elevation. So I will start typing and it will direct me that yes, that particular column is there. So I am putting it under inverted comma. Okay, double inverted comma. Minus what is the depth to water table, that is May 2024. So again, 2 open inverted comma and then May, I will start typing it, okay? May, and it will direct me that yes, that particular column is also there. I will put it there. You will see a preview. It's getting generated, okay? And then I will click on apply. When I click on apply, that groundwater elevation for May 2024 has shown up there. And now I will simply click on OK and OK. So groundwater elevation is there. You can save this. Make sure that you save it. Okay. Okay. Yeah, that also you can do, but right now I don't think we will require that extraction, so we will keep it with this. Don't worry about it, even if you don't do it. If you want them to be extracted, go ahead and use it. You go ahead and extract that dem, but right now we don't require it. Okay, good to go ahead with this. This is good. Now what we will do, we would also require for August 2024, isn't it? So for that, what we will do, you can go for generating one more field first itself, okay? New field. We will create a new field. What is that new field? It is groundwater elevation for August, okay, for August 2024, and type is again going to be decimal number. We will click on OK. So one more column you will see showing up here. And then what I will do, I will go for clicking on the same button, that is open field calculator, and I will go for updating an existing field. Which is that field that I'm updating? It is groundwater elevation 2024. Okay, and then I will go ahead and add an expression. What is the expression that it is? It is elevation minus, put it into comma, minus, okay, not minus, then next column is August. August 2024. Put it into this. Uh, okay, it's all right. And then if you get this question mark, that means that particular field was empty. That's all that it means. You can just simply go ahead and apply. Okay. That happens because of that question mark. That means that particular data was not there. So you will see in that the CSV file that we have created, at some places dash was there. No, preferably you remove them, because if dash is there, that doesn't mean you can replace it with zero. Okay, you will have to remove it, and that is why it is not taking it, because at places that this question marks means basically that measurement was not taken at that particular point. So you can replace them with maybe some anomalous values or something like that, or you can altogether remove those particular rows itself. That also can do. But right now we are ready with this groundwater elevation May 2024. So let's go ahead. Okay, let's go ahead. Okay. Now next what we need to do, we need to interpolate this data. No, we have already generated groundwater depth. We have generated groundwater depth for May 2024. So let us go ahead and interpolate it. So how do we go about doing it? We go to this section, this particular toolbox that is called interpolation. Okay, we go to interpolation and we use this IDW interpolation. A very simple interpolation, that is IDW interpolation. Vector layer is not demo file now. It is sampled elevation file, because this is the complete one. Which attribute do we want to interpolate? We want to interpolate the groundwater elevation May 2024 data. Add it to this particular table. Use this green plus sign to add it to your vector layer that needs to be generated. Distance coefficient P, read a little around this distance coefficient P, because often when you use ordinary kriging and things like that, there also these things are asked. Usually 2 is the best, by default is 2. Extent we need to give, extent. For that you can use whichever layer that you want. I want to use Goa UTM. Okay, I want to use Goa UTM. Now you need to write as to what is the pixel size that you want to give. Now keep this in mind that 0.009 is 1 kilometer. That is almost 0.01 is 1 kilometer. This is in terms of degrees. Please keep that in mind. So you can change either one. Either you can change the row, how many rows will be there, rows of pixel. Okay. Now in a row, how many pixels will be there, or in a column, how many pixels will be there, the columns will be there, or how many rows will be there, or you can choose what will be the x size and y size of that pixel. I want to keep this as 0.01, that is 1 kilometer. Okay. So I will make this 0.01. This is what I want to keep it. So what will happen? Everything else will get adjusted accordingly. I hope you understood this. Let me know if you have not understood on what basis I have given this as 0.01. 0.01 means almost 1 kilometer, little more than 1 kilometer by 1 kilometer to that pixel that will be generated. Okay. And then I will go ahead and save this to file. Don't try to change for X and Y both. Okay. You will be able to change for only one, either X or Y, or you will be able to change for rows or columns. That's all. You cannot change all four. Let me save this. What is this? IDW for groundwater elevation. Okay, that is a potential head, groundwater elevation. And then I have used what? I have used May 2024. Okay, this is for May 2024. I have used IDW interpolation method. Groundwater elevation data I have generated for May 2024. That is what it means. Please follow these kind of nomenclature practices whenever you are saving any data. Let us go ahead and save this. I'm saving it in the same folder. You will see open session folder that I have made, and I will click on run. There seems to be something going a little wrong with it. You can check the log message pan. Not generated. Okay, was not generated. Let me see what exactly it is to do with um, points is correct. It has to be points. Is it because they are not in UTM? Maybe because they are not in UTM. Yeah, it's okay. If you want to escape, definitely go ahead and escape. But if you want to stay back, another 10 or 15 minutes we will take. Okay? Because the live sessions cannot go strictly to 1 hour. We plan for 1 hour, we definitely extend because everybody needs to uh, go ahead. Okay, all right. Okay, so right now it's just not going ahead. What I will do is I will convert this particular layer into UTM. Very simple. I will select this layer, I will go to export, okay, and I will save this feature as, and this time I will go for saving it as GWD just one and then save. Okay, I will change this coordinate system to UTM zone 43. All right, and then I will click on OK. Now, usually this is required, so now I will end up using this GWD1. Everything will be same basically in that, so not a problem. Okay, so I will go back again to IDW interpolation and I will add this GWD1, and then the interpolated layer that I require is May 2024, and I will add these points. By default it comes, so don't worry about it. Extent, I want to calculate it from UTM Goa, okay, and I want this to be, this basically one means that it will be 100 kilometers, so I don't want it to be 100 kilometer, I want it to be 1 kilometer. Okay, let us save this. I want to save this as groundwater elevation following IDW for May 2024. And let's save this and run. Is this, I'm doing something wrong? Calculate from, let me just calculate it from merged SRTM. Let's see what happens, okay? Let's run this. Yes, I have used merged SRTM. It has run algorithm IDW finished. It has been saved. It's like it has been saved. Let's see where exactly it is. I'm just zooming to that layer. Where, in an awkward place. Let me know if in your case it worked out. Yeah. Yes, yes, yes. Rho is coming as 163. 0.01. Let me try to take this as 4. Let's see. Saving it correctly. TM zone is also correct. Let me just figure out what exactly is going. These two are just giving the same values to me. So definitely this is incorrect. We remove this. Okay, points. If I go for structured lines, it will directly give me contours. Just give me some time. May 2024. This is correct. If I remove the extent, let's see, and then everything else is fine. Run this. Wrong missing parameter value extent. Extent is required. I should go for UTM zone itself. This is correct. Methodology is correct. I'm thinking what exactly is going wrong. Parameters. Take it back to this. Seems to be not changing, but it's very awkward. Let me just rename this. Maybe I should call this one or something like that and run. Oh God, this should not happen. It's just not changing. Oh God. Groundwater elevation. Okay, I'll just right now keep this as 0.1. That is actually going to give me huge pixels. That is also there. Let me save it as a temporary file. Let's run this. Is because something wrong with it. Okay. So for now, let me just bring in a file that I have already created so that we will move ahead and then I will come back here. Okay. So the file that has been created already. Please excuse me for that, but I'm not able to stay behind for that. I hope it has worked for any of you. Please give me, drop me a message if it has worked for any of you because that was the actual methodology. Seems like something has gone wrong in there. Okay, so this is groundwater elevation PNG. Groundwater should be 2024 to table elevation. Okay, so let me just show you the file that has already been created. Okay, so this is how that particular file looks. I want to give it some color. Let me just go to the properties, change it to single band pseudo color, apply. Okay, I'm choosing this particular color name. What is that? It is this turbo. Okay, and I'm applying it. It's a linear stretch. Let's apply this. This is how it looks. So wherever you have brown color or red coloration, that means the groundwater elevation is pretty high at those places. Okay. So from these point locations that we had, we have interpolated groundwater elevation for the entire study area. Now, I want to generate potential, that is piezometric level heads also for this. So what do? I select this particular layer. I come to raster, and here you will see extraction. Okay. And under extraction, you will see contour. So I go for contour. The input layer is this Goa IDW May 2024 water elevation data that you have saved. And then I want to sample these contours at every, let's say, 2 meter. Okay. At every 2 meter, I want to extract these contours. And then attribute name, what it is elevation. If you want to change it, you may change it to piezometric levels or anything like that. Okay. I'm just calling it piezometric level, PL. And this will be 0. That means each contour will be offset from 0. So the base level will be 0, 0 contour, then 2, then 4, and so on and so forth. You can save this particular file, that is a contour file. It will be a shape file. I want to save this as piezometric levels. Okay. Contours for groundwater elevation for May 2024. And I will save this. It will be a shape file. Let's save this and click on run. So when I click on run, you will see the contour lines for this map will be generated. Let me change the color of these lines so they become more apparent. Apply, click on OK. Okay. You can label them as well. So what it is, we go to properties and you see label here. Right now, no labels. You will apply single label. And which value do you want to give it as label? Definitely this PL, that is piezometric level head. You can change the font to whichever font that you require it to be. I want it to be at 12 font size. Apply, and now you will see that these contours are also named. So you see a high elevation of water table here. Okay. Higher elevation here, higher elevation here in the Western Ghats. Okay. Okay, so for work. All right. Okay. For some it has worked. Let me go back to this. Okay. Let me go back to this. Just need to. Meanwhile, if you have any query, please ask. Let's talk about that. Well, I'm just figuring out what has gone wrong with my data set. Okay. Seems to be something, and then it's just not showing me what exactly it is. Let me try changing these rows. Let's see what happens if I change this to rows. Let's run this. Yeah, okay. Now it has generated. Seems to be something pretty wrong with this. Okay. It has generated, but all of them is same. Oh my god, this is troublesome. Okay, meanwhile, let me share these water table elevation map with you so that you will be able to generate the contours. Okay. So I'm sharing this ID related data set with you in our uh, shared demo drive folder. So please find it from there and let me know if you have any query. Okay. So I have prepared this one test for you. I'm sharing this link in our chat box. Please attend to this particular test. And meanwhile, let me just figure out what exactly is going wrong with the IDW interpolation. If that doesn't work, I will show you yet another, provided if you have time, because we have already reached 90th minute. So I wouldn't want you to wait for very long as well. This is the test file. Okay. There are a few questions there. Uh, Attend to this and I will send you a certificate for this particular open session. But let me just figure out what exactly has gone wrong with this interpolation. There seems to be something going wrong with that. It's just not working. जायच ना. किती आलंय? कैसे? आउटपुट लोकेशन सारखे ना आपले? आउटपुट लोकेशन किती आहे? म्हाका दिसता हे दोन्ही मॅच जायना झाला माझे. एक्सटेंट मॅच जायना झाला अशें दिसता म्हाका. रॉंग जिओमेट्री एट्रिब्यूट सिलेक्ट केला. हय ना. सेम CRS यूज करताना जाय. सेम CRS असूंक जाय. That is correct. CRS. तो इकडे UTM, BEM आणि सिंपल डिव्हाइसेस आहेत. काहीच कळना झालं. All your both your files, that is the extent file that you're using and this shape file that you're using should be in the same coordinate system. That is true, but we have already made it into UTM. I'm still wondering why it is not working in my case. Okay, seems like it has worked for this at least. Zoom to layer. Yeah, it has worked. So what I have done is I have used this same IDW file that I had created earlier for the extent. Make sure that your extent file and um, your this sample file that you are using, both of them are in the same coordinate system. That's all that you have to make sure. Okay, make sure that your sample file, that is the shape file that you are using, and the extent file that you're using, both of them are in the same coordinate system. Now how do we ensure that? We ensure that by right clicking on this sampled file. So this is our sampled file. We go to the properties and the source of it, and this is where you will see um, the assigned coordinate system. So here it is UTM zone 43. Also mind this EPSG 3243. Okay. And then I was earlier using this Goa UTM file. So if I go to the properties of this 32643, oh, this seems to be correct, but still it was not working. 32643 UTM zone. 32643 UTM zone. Then I go to the properties of this 32643 UTM zone. Yes, it's correct. Oh, since still how it was not working earlier, but now it has worked. So this is the interpolated layer. What do? I can put it into single band pseudo color, apply. So this is your layer, but then right now it is not clipped to your Go shapefile, isn't it? It is not clipped to your Goa shapefile. So for that, what we need to do? We need to extract it using this particular UTM zone shapefile. How do we do it? We come to raster where we have extraction, and here you use clip raster by mask layer. Okay. And we are using this interpolated layer. Okay. This interpolated layer, and the mask layer is our Goa UTM. And then we can save this. This will be in UTM zone 43, and save this file to our folder where I was calling it IDW groundwater elevation for May 2024. And then we save this, run. You will see that it will be extracted. Let me just bring this here. Okay, so it has been extracted. Now what you need to do? You need to provide it with some color just for a better visualization. Give it some color. Let me take off anything else other than that. And then what did I say? I said that we need to apply some contour to it. So for contouring, we go to again extraction, and here we use contour. We use that particular layer, and depending upon how much interval you want, this time I will extract it at 5 meter. Let me know if anybody is facing any difficulty. Okay. Finally, it has worked. So I would want you to pay attention and then fulfill your task. So save this file. I am saving this as Goa IDW May 24, and this is groundwater elevation. And save. Okay. And then run. Okay. So now we know that these are the contours. This is where we have higher water level elevation. That means from here, water will, that is groundwater, will move perpendicular to all these lines, to all these contour lines or piezometric lines. This is how we generate our flow lines. What exactly are flow lines? Let me show you by creating just one flow line, and then you can go ahead and generate as many that you want. Okay. So let me go to layer and create a layer. I will create a shape file. The geometry will be a line string. I'm not naming it. If you want, you can name this. Let me just create a temporary flow line. Okay, temporary flow line, and I'm taking UTM zone 43 because I want to measure what is the line and things like that. So let's click on OK. I will be able to start editing it, toggle editing it. Okay, and you will see that lines will show up here. Okay, you will see this section where lines will show up. I can take this line and I will draw perpendicular. So from here to this flow line, to this flow line, then I make sure that I go perpendicular. Okay, I cannot go tangential like this. I have to go perpendicular. Then draw as many lines as you want. Make sure that you are perpendicular, going perpendicular. Because what happens is water always takes the shortest distance from higher elevation to lower elevation, or essentially the potential heads that we call. And you will see that you will end up creating flow lines. So from here to here, when it moves, it will make sure that it goes in a perpendicular fashion or near perpendicular. And that's where will come into the coastal reaches. Make sure that you're following perpendicular. And from higher elevation to lower elevation. So in between here, what is happening? You will see lower elevation. And that is where you can generate, you have ended up generating one flow line. Okay. If you want to find out its length, likewise, you will be generating multiple flow lines and you will be able to find out what is its length. How do you go about doing it? Take this open field calculator, create a new field, and you are going to name this length. This will also be a decimal number. And in the expression, you will search for feature geometry, that is here geometry, and search for length. That is length is here. Double click on it. You will see a preview. This will be in meters. That means right now it is 20,973. That means it is almost 21 kilometers. So apply and click on Okay, so you will see flow length. That means what? This groundwater that is reaching in this particular area is coming all the way from here. How long is it traveling? It is traveling for almost 21 kilometers until it reaches its nearest discharge point. That is what it means. Now, because I'm doing it for the entire state, it won't make a very critical and accurate sense. But if I was to take one village and measure groundwater depth for every month, for all the wells that are present within that particular area, that I am in a better position to find out what is the direction of groundwater flow. Okay? Yes, yes, correct, Mansi. Right. The projections have to be same. Whenever you are using two files together, make sure that the projection is same. If the projection is not same, then you can go for reprojecting it. Okay. Use this for reprojecting it, reproject layer, that is for vector, and you also have it for raster, that is align raster. You can use these tools to reproject it, or like I have shown you, you can go for exporting it. For example, this, you can right click, go for exporting it, save feature as, and while you are doing this, select your accurate coordinate system that you want to reproject it in. Both these, that is raster and vector, will work in the same direction if you use this particular method. Rather than going for align rasters and for reproject layer, you can use this particular method, that is project. Okay. All right, so that is the end of it. I will be sharing one link with you for creating groundwater elevation maps. Let me show you few maps that I have generated, and then we are done with it. So this is a map for November 2024. This is for May 2024. This is for August 2024. This is for January 2024. You'll be able to see how essentially these contour lines are changing. Okay. Here the potential head is taken at a 2 meter difference. The interval is 2 meter. You can see how it changes. Essentially, the changes are in the coastal region. Okay. Let me share a feedback form with you. Please provide your feedback. We were trying this YouTube live for the first time, anticipating that many people have joined and they all will participate, so that Google Meet will not work. But I hope you learned something in here. Let me share this particular feedback form with you. Please provide your feedback. If you want to say something, you may drop that question in your chat box. Let's talk about it. Yes, wait a second. Feedback form. Okay, so this is the feedback form. Please fill it up. And also the test that I have shared with you, only 5 questions are there. How to reduce the boundary area? If you, what kind of boundary area will you be interested in, Sampa Sardar? Is it taluka level boundary that you are interested in, or village boundary? If you're still around, you may please tell. The raster file, the map boundary. In the raster file, the map boundary. Oh, in that case, you will have to take that particular boundary that you are interested in. For example, if you want it only for a specific taluka, then you can export that taluka from again here, no? That is from level 3. So you will see level 3 is essentially talukas. Okay, if that is what you are interested in. But if you are interested in village boundary shapefile, then you will have to download it from Survey of India, or there are quite many JSON files that are also available out there. You can take JSON files for a state's or a district's village files, and just copy all those polygons or that file that you see, because that JSON file is usually not downloadable. So you can copy all that content, paste it in a notebook, convert it into a text file, okay, and then rename it as .json rather than .txt, which is there. Just replace it to .json, and then you will be able to import it using the same that is add delimited text layer, the same one, or the vector layer also you can use to bring those JSON files. So you will get a village file. But if you are interested in watershed, then you will be able to download it from hydroshed. Let me know if I could answer it, because I'm a little confused about the question also. Raster file, the map boundary. If you feel that these pixels are too big, then prefer to go for smaller pixels. So smaller area you can go for. Rather than 0.01, that is 1 kilometer, you can go for smaller. Maybe from for 0.001, something like that. Just find out what is the equivalent of the degree. From Google, simply you can find out. If you ask Google, let's say your pixel needs to be 30 meters. So you can simply ask Google, no? That is 30 meter in degrees. Okay, so it will tell you 30 meter in degrees will be so many. How much it is? 0.00027. That will be 30 meter. Okay. If you feel that adding rows and columns is not going to help you, then this is what is going to help you. So this is a test file, and that is the feedback. I will I'm a little doubtful about the feedback, but I hope everybody learned something. Can you please give me a thumbs up if it was beneficial to you? This same kind of maps you can generate using no matter what kind of data, but please mind your projection. We will stop here. I will stay back. If you have any query, let's take 5 minutes and then we will stop. Meanwhile, I will just generate a map for it. It will be there for the record. Create a simple map. I go to project, new print layout. I'll give it a name, groundwater elevation. Okay. Adding an item, map, that is. I will use this option, that is move items, to just zoom in and zoom out and adjust it so that everything gets covered. Let me add a scale bar. Okay. And the scale bar properties are here. I want there to be 2 units on the left. That's why I'm doing this. Let us add a north arrow. You can choose whatever arrow that you want from here, from this arrow section here. Okay, I like this one, but the size is, and I want to change its color from white to maybe gray so that N becomes legible. Okay, let me give a frame to this. I'm just checking on the frame. Great. Let me add legend. I'm doing it roughly, okay? I will share a video with you how to do it, but right now, if you are doing it, you may. I'll just check off this auto update and I will remove everything else using this minus sign. Everything else I'm removing. I'm only keeping what I require, okay? And I'm not happy with this font, so I will change it to Times New Roman or whatever that you want, not a problem. Times New Roman, and you will have to change it at multiple levels just to be consistent. Okay. If you want, you can change the symbols. For example, I want this symbol to be a little lengthier. So I'm changing its height. I'm increasing its height. Oh, sorry, not here. Symbol size, maximum symbol size. It's, I just want to change it for this. Okay, yes, it's becoming lengthier. Huh? Okay. And what else do I want? Let's say I want some grid. So for this map one, I'm just adding some grid. We'll see grid, add a grid and modify it. I'm changing it to 5 to 5. Great. And draw coordinates. Let's stick it on, but I don't want it to be for all. I want it to be present for left and I want it to be present for top. That's all. Bottom I'm disabling. I'm just disabling it all. You can choose what exactly you want. You want a degree, minute, with second, with suffix. This is how you want, however that it is. Okay, I would like it to be like this. Then seems to be too congested, so I will change this to 0.1, so it doesn't look congested. I want to align this. This seems to be fine, but this one I want to make it vertical. So for that, that is left one, I want it to be vertical ascending. I have changed it. And if at all you want, you can also um, uh, these grid lines that you see, no? Let me go back to the grid, modify grid. I want this line style to be changed a little. Maybe I would want it to be in little faint. Okay, little faint. So seems good. Okay. So that is the map. I don't want this to be opaque. I don't want a background for this. So I just checked off the background. And if you want to change the font color of this grid, no font type of this grid. So I'm going back to the grid and I want to change this appearance. So that is here, font. Okay. Change this to Times New Roman. And yes, this seems fine. Well, great. Okay. Let me export this map. Export as an image. I will save it again in the same folder, groundwater elevation. You can give it any name and things like that if you want. May 2024. Saving this. You can change the DPI. I prefer to keep it at 300. That's best. Let's save this. And it will automatically open. Okay, so this is your map. If you want to give it any title, let me show you how to do that. Add item. There are many things. You can add dynamic text. Okay, layout name. Just add the layout name here. You can change it here in the main properties. Groundwater elevation for May 2024. And then definitely you know how to change the font type and things like that. So let me tuck it here, and I will change its font to Times New Roman and make it bold, whatever size that you want. Very simple. Okay, tuck it wherever that you want. If you want it here, do that. Okay. Yeah, you can hide the grid lines as well. Definitely, you can hide the grid lines. So if you take this map one and you go back to the grid, okay, modify grid. Like right now, what I have done is I have kept it very faint. I can also take them off. How do I do it? Do that? I just make this 0. If I make this 0, no, width is 0, then it will be gone. Or the opacity I reduce. Okay, I reduce the opacity. I completely take off the opacity. That will be there. I want to keep it a little. You can also add tick marks because without that it will be difficult, no? So for that you can add these tick marks. Right now it is no frame, no? You can go for interior ticks or you can go for exterior ticks, okay? Or you can go for this zebra. This also you can do. Okay. The main things in this frame within the grid, no? Within the grid itself, I will go for internal trick ticks within the grid. This is for grid. Okay. So let me see you someday soon for yet another open session. Please provide your feedback. I would love to hear from you as to how you conceived this particular open session. We are holding it for the first time on this YouTube. Otherwise, it was always on Google Meet. We were expecting many people to join at the same time, and that is why we thought we will go on to YouTube Live. I had never tried it. It's great. I hope you learned something. Please provide the feedback. The links are shared in our chat box. Please refer to them. And I will see you someday soon for yet another live session. Please subscribe to Pravinya Research for any more tutorial. You may go through our channel. There are many more other tutorials as well there.